Hello Internet, my name is Quinn and this is Blondihacks. This is part 2 in the hydraulic cart hinge project. In the first part we built the top half of the hinge, and now we're going to build the bottom half. Engineering plans and 3D models for this project are available on my Patreon, so go ahead and check out that link down below. Okay, let's dive in. Okay, so a quick review of the Fusion 360 here. You can see the bottom hinge in yellow there is what we're making this time. So it's a cylinder with 2 different diameters and kind of a fork on one end. Okay, let's get started. So we start by facing off the end of the stock and center drilling for tail support. There's our old friend, the number 2 center drill. And a little bit of Sharpie here to mark off where our diameters are going to be. This is one of my favorite tricks in machining, is using layout fluid or Sharpie to blue an area and then hooking the calipers over the edge to mark it out. Okay, so let's get started turning our stock down to diameter now. We've got, as I said, 2 diameters to do, so I'm doing the smaller one first. Another way to do this would be to turn the entire thing to the largest diameter and then continue turning the smaller diameter, but this method also works fine. And we're getting nice chip action here. This is 12L14 free machining steel, which I like very much. Alright, and our finishing pass here. So we've got a much higher spindle speed and a slower feed to try and get as nice a finish as possible on the last pass. Alright, now touch off, and we're going to turn the larger diameter. A bit of cutting fluid there. And ease it up to the line. Okay, now we're close to dimension because our final part is not much smaller than the stock here that we had. So this is our finishing pass. Again, slow feed and higher RPM to get as nice a finish as possible. Alright, so we're ready to part it off now. So I've got my parting tool set up here. You always want lots of cutting fluid with parting and a real nice slow spindle RPM. I usually start off at something like 75 RPM, and then I'll increase my speed as the diameter gets smaller to keep the chip action working well. And I put a little paper towel down there to keep the part out of the chip tray if it should happen to fall, but usually with the tail support, the part just kind of stops and stays where it is after the parting tool makes its way through. And we're getting nice ribbon chips off the parting tool there, which is what you want to see. So at this point we're up to about 150 RPM, so we get very close to the center. And there she goes. Alright, so now we're in the mill, and I'm using the edge finder to center up, and the way this works, if you haven't seen it before, is you use the edge finder to find one side, and as soon as it bumps over, you've got the edge, so you zero the DRO, and then you move to the other side on the same axis and do the same thing. You move it in until the edge finder bumps over, and then you use the half function on the DRO, which takes those 2 measurements and finds the midpoint, and then that sets your 0 to the center line of the part, which is very convenient. Alright, that guy bumped over, so now I hit that half function on the DRO. Now we're centered up. So center drilling now for the cross drilling operation that we're going to start with. And this is for the hinge pin, so we are drilling 1/64th under the hinge pin size, which is 250 thou. The hinge pin is going to be made of 01 tool steel piece of drill rod, so this will be reamed to a precise dimension so that the hinge fits nicely. And then we're going to ream that to final dimension. So I've slowed the mill down, lots of cutting fluid, and go nice and easy with the reamer. Clear the chips often. Reamers are unlike drills in that they don't have those spiral flutes, and so they can't clear their own chips. So you need to give them a little help and pull that out and clear the chips pretty frequently. Now we're setting the part up vertically in a collet block, and the bottom is not touching because the back there is not machined. And I'm using a dial test indicator to get it vertical. And I'm embarrassed to say the center of my block's pretty dirty there, so it's bouncing around, but the top and bottom are 0, so we're good. And so now I'm using a 1/4 inch 4-fluted end mill here to cut the slot. And I'm milling on the y-axis of my mill, which is less convenient because I don't have a power feed there. But this way the setup is more rigid because if I try to mill on the x-axis, then I'm relying on the friction of those vise jaws to hold the part vertical, or else I have to rotate the vise and re-indicate it, which is a lot of effort. So it seemed easier to just cut it on the y-axis and feed by hand. And you can see I'm using an extra long end mill here because the slot is pretty deep. I could have also milled this part horizontally, but I wanted a square bottom in the slot mainly for aesthetic reasons. If I milled the slot horizontally, it would have a rounded end from the profile of the end mill. Although truth be told, a round profile would actually be stronger. A rounded fillet on an inside corner is always stronger because square corners create areas where the stress can focus. Okay, so there's a quick test fit, and it's looking really good. And you can see how it'll hinge there once those ends are rounded over. Okay, now we're going to drill and tap the mounting hole. This is where a bolt goes through the cart and secures the bottom of the hinge. And this is to match a mounting hole or a threaded hole that's already in the cart, is how the original factory handle was secured. So there's our tapping drill size there. And just tapping this by hand using a spring-loaded tap follower in the mill. You can see that the end of my tap follower is falling apart there. Luckily, it still did the job. All right, and that is our final 2 bottom hinge parts. You can see that the ends are rounded over, but I'm not going to show you how I did that, so you'll have to tune in for the 3rd part of the series to find out. Thanks for watching, and I'll see you next time.